Hello, my name is Tanya Jean, and today I will be talking about iterative data processing with deep transfer learning. We're going to start with an introduction and go into deep learning to deep transfer learning, and about the survey that was used as an example for deep transfer learning for kidney and cancer diagnosis, and then followed up with the advantages of deep transfer learning or DTL, and then the conclusion. So, the introduction to deep transfer learning and data science, it refers to the process of applying knowledge gained from one domain or task to improve the performance on a different but related domain. And this is particularly useful when there's a lack of labeled data in the target domain. So in this case, being image recognition versus having solid data sets as we're used to having, but allowing models to leverage learned representations from a larger labeled data set for a similar source domain is basically the premise of it. So, one of some of the benefits, it improves performance on related but different tasks, and it's useful in scenarios with limited labeling data in the target domain, like mentioned, and it leverages the representations from larger labeled data sets and similar source domains where basically the information on the input is pre-trained information. So we'll get a little bit more involved with that when we step into it now, talking about deep learning to deep transfer learning. So there's features and applications for deep learning. It uses the neural networks with multiple layers to learn data representation. So hence the term deep. And these networks can automatically learn complex patterns and hierarchies within data. And it just makes them so powerful for tasks like image recognition, language processing, and speech analysis. So things like that are kind of intangible or just kind of like kind of anomalies or kind of hard to group together. Deep learning has that advantage in that it can uh, uh, use that information learning in order to better make predictions based on these type of factors. So in deep learning models, they're typically trained from scratch on large labeled data sets. But and then the goal is to optimize the model for specific tasks within a single domain. So DTL, extending deep learning. So basically, look at it as deep learning, but extra. It goes an extra mile. It uses that information learned from transfer learning, and it goes into a deeper representation learned by the deep learning model, trained on one domain, the source domain, and applies it to another domain. In DTL, the deep model is usually pre-trained on a large general data set, like an ImageNet for images, and then it's adapted or fine-tuned for a new potentially related task, often with limited data in the target domain. So the key idea behind DTL is to transfer knowledge learned by a deep network in one setting to improve the performance in another setting, which may have different distribution or limited amount of labeled data. So just to kind of make it a little easier to kind of see the difference between the two, I did put together a table here that we can look and kind of get a better idea. So in deep learning, a training approach, the models are trained from scratch on a specific task, whereas in a deep transfer learning, the models are pre-trained on a large source task, and then this knowledge is transferred and fed into it to improve the performance on a related target task. So it's basically taking the refined or the pre-trained information that already has some calculations and predictions, and that model is fed into deep training kind of in an iterative format. Then the data requirements for deep learning is you just need a large labeled data set. You're required to have a large data set that is labeled to achieve the high performance, but In a DTL or the deep transfer learning, you can work effectively with limited labeled data in the target domain by leveraging that knowledge learned in the original source domain. And the domain and task adaptation focuses on a single domain in deep learning, while in deep transfer learning, it adapts the knowledge from one domain or task to another and often uses techniques like fine tuning or domain adaptation to reduce the domain difference. So in section 3, we're going to go ahead and this was the survey or the journal that I used to, to kind of like give a correlation between the practice of DTL and transfer learning. It's about the deep transfer learning for kidney cancer diagnosis. So you can imagine, you're dealing with something different. You're dealing with different data sets at that point, not necessarily tables and Excel spreadsheets or things like that. You're looking at images. So you may have hundreds or thousands of images, different images, and just trying to find a correlation between them. So in this article, um, it kind of gave the distinction between deep transfer learning and transfer learning, and it centers around the use of deep learning architectures and DTL, which provides several key advantages over the TL methods. So, in comparison with traditional transfer learning, um, the hierarchical feature learning, deep transfer learning leverages deep neural networks, what we talked about. And in contrast, traditional TL approaches may rely on manually engineered features or shallow models, which lack the same depth of representation and may miss some complex image characteristics important for accurate diagnosis. And then hierarchical clustering, in a sense, if you want to look at it like where it takes putting each data point in their own cluster and then merging those clusters together based on some rule, right? So in the same case, you have these images where you're making correlations and similarities and clustering, and those things. Say, well, based on texture or based on different characteristics, you can make different predictions based on that. So it has a higher performance in complex data. We talked about that. It's deep with neural network architecture. It can handle complex high dimensional data like medical imaging, MRIs and CT scans, and more effectively than the standard or traditional TL. And then the standard TL methods may struggle with such a high dimensional data. And they're not inherently designed to model complex structures as as the deeper networks increase. So the increased adaptability for medical imaging, the DTL provides a greater adaptability for various image models, and it just allows to generalize them. And typically, the medical images and even different imaging devices or protocols. So by fine tuning those layers of a deep model pre-trained on a large general data set, DTL adapts well, and then traditional TL just lacks that flexibility. So the survey deep learning transfer architecture. So the article discussed the use of various deep learning models such as convolutional neural networks or CNNs, not to be confused with the broadcast network, but it's commonly applied to image recognition, as we mentioned. So particularly for analyzing medical images like CT and MRI scans. And then these architectures are integral in the deep transfer learning as they provide hierarchical feature extraction from complex visual data and medical diagnosis. Then the transfer learning frameworks adapts pre-trained models from general data sets for specialized medical imaging tasks. Then the medical imaging technologies, again, CT scans, MRIs, ultrasounds, those are the things that, in terms of kidney diagnosis, those are the data sets that you're dealing with. You're not dealing with the traditional data sets that have labels and things like that. So this addresses the challenges in processing and analyzing medical images with deep transfer learning models. So this was an image That was in the survey for the Journal for Deep Transfer Learning and Kidney Cancer Diagnosis. And I thought the authors did an excellent job. Yassine and the other authors that created this image, and I'm giving them credit for it because it was a very good display of the transfer parameters or the weights, right? So from the CNN training, for example, on the left, you see that, of course, it's a large databases, is using a traditional um, uh, uh, way of learning, right? The learning transfer, and then the predicted output that comes from that source label, right? We talked about the domain source. That is now the input for the deep learning transfer, and that's a smaller subset, a smaller uh, uh, basically a smaller database, a target for that's the input that's used, and it goes through a modified CNN retraining for the kidney data. So then you get your predicted kidney data results as a result of that. So basically, this I thought this image gave a great visual of how the architecture design looks and for uh, prognosis or predicting that type of data. Uh-oh, didn't mean to go to the conclusion. Let me slide back. So advantages. Let's go over the advantages of transfer learning. Yep, the advantage of deep transfer learning. There's several of them. The benefits overview reduces data needs. It performs well with limited label data. It's faster and cost effective. It has an improved performance, so enhances accuracy in related tasks. As pre-learned features kind of help generalize better in the target domain. The cross domain adaptability works across various domains and modalities like images, text with domain adaptation techniques, and it supports few shot learning. So enables with minimum data, making it ideal for specialized and high cost data fields. So as a result, deep transfer learning is efficient, it's versatile, and it boosts performance and reduces the cost. So especially when we're dealing with data limited scenarios in these cases. So in conclusion, um, the efficiency of medical imaging, a summary, the article emphasized the deep transfer learning is better suited than traditional TL for handling the complexity and variability and high dimensionality of medical imaging that for data in kidney cancer diagnosis. And it leads to improved accuracy and adaptability in clinical applications. So thank you so much for your attention on this. If you have any questions, you may feel free to email me at tanya.john@sjsu.edu. Thank you very much.